Hello everybody, welcome to my presentation of Transport Layer Protocol. From now on, we have discussed the bottom three layers, the physical layer, the physical medias of the network, and the data link layer, the Ethernet protocol, and then the network layer. In the network layer, we discussed the three protocols, the IP protocol, and the ICMP protocol and the AIP protocol. Now, we come to the fourth layer, the transport layer. In the transport layer, there exist two famous protocols. One is TCP and another is UDP. Okay, these two protocols are all based on IP protocol in the third layer. Okay, and these two protocols, the difference between these two protocols is TCP is connection oriented. That means when TCP is sending data between two stations, between two hosts, they first need to establish a connection. And when UDP is sending packets between two stations, they did not establish the connection. Okay. Then, in this chapter, we will discuss the difference between TCP and UDP, and we will discuss the format of the TCP header and the UDP header, and we will understand the port, the important element, the important field in the TCP and UDP header. Okay, first we see the TCP. The full name of TCP is the Transmission Control Protocol. And we have already mentioned that the TCP is connection oriented. That means when host A wants to send a data to host B, then first need to establish TCP connection. Okay. After the TCP connection is established, then the packet can sending through this connection. Okay, of course, because the host A wants to send, so the host A should originate the connection establishment, sending a request, and of course host B will reply to establish the connection. Okay. First, after the connection is established, then the TCP and UDP will sending data each other. In the TCP and UDP's header, it's the same. Okay, there's two important elements. That's the port. The port, there's two port number. One is the source port, and another is a destination port. As we know, the TCP and UDP are transport layer protocol. Above them, there's application protocols. In the TCP itself, one transport layer protocol can support many application layer protocols. Then, how to identify each application protocol? Use the port number. Of course, there's two port numbers, source port and destination port. Usually, we use destination port. Okay, destination port to identify which application should this packet send to. Okay, and source number, usually it's randomly chosen. Okay, of course, these two both will identify one session. Okay, identify one session. Okay, then we can see if the destination port equals 20 or 22, 21. Okay, this is the protocol, famous protocol FTP. If we use HTTP, then we use the port 80. Okay, of course, it's the destination port. It's 80. Okay, the initiated host sending a packet to the destination port 80 means to access the HTTP server, the web service of this server. Okay, of course, when the data is sending back, then the source port and destination port is reversed. Okay. Then the telnet use 23. The SMTP, this is used for email. The simple mail transmit protocol. It's the port 25. Okay. This is the TCP port. Of course, there are still many other ports. Usually, the port smaller than 1 kilo is already assigned to well-known services, and above 1 kilo is dynamically assigned by services or assigned by applications used as the source port. Okay, this is the TCP port, and then we go to the TCP headers format. The TCP, of course, in the IP header, there's a field, the protocol, that use the protocol number 6 to figure out the transport layer protocol is TCP. Okay, then in the TCP, this is the TCP header. In the TCP, first source port and destination port, we have explained that's a destination port to identify which application should access. And the source port usually is randomly assigned by the source host. Okay, and then this is the sequence numbers. Okay, we say that TCP is connection oriented. So the connection oriented means the two servers, the two hosts should connected. What's connected? They will confirm which packets, which bytes I have received and which have not received yet. Use which, just use the sequence number. Use the sequence number to confirm that I have received how many bytes from the sender. And of course, when it's self sending out, to assign the sequence number of the packet. Okay, and here, Windows. The Windows just to improve the mechanism of the connection. That means if there's no window, that each packet sending from source to destination should be confirmed. Okay, but if we got the window, that means the receiver did not need to confirm each packet. The sender, the source, can send out many packets, several packets at once, and then the receiver confirm at one time. Okay, that's the many packets confirm once. Okay, to improve the speed sending from source to the destination. Okay, and now this is the length, header length. That means the TCP's header. Of course, there's a fixed part is 20 bytes, but there's options. Okay, so it's a variable. Okay, the length is variable, and now there's many flags. Okay, many flags, but some flags is important. The sync just to synchronize the sequence number and the window size between the source and the destination, because it's a connection oriented. So when they establish connection, they need to inform the other side, I will use which sequence number. Okay, use what window size. Okay, just the sync. Okay, and then the acknowledge. The acknowledge just to confirm how many bytes I have received. Okay, and then the finish just to disconnect the connection. After the data have finished sending between the source and the destination, then the connection will be disconnected. Okay, so use the finish and then reset just to reset the connection, disrupt the connection. Okay, this connection will never use the more. Okay, this is the reset. Okay, and then we see the mechanism of TCP connection establishment. The TCP connection established uses the famous three-way handshake. Okay, the three-way handshake that says when the host A, if host A wants to access the server, okay, for example, the web server, then first the host A will sending a sync packet. The sync packet means the flag sync is set to 1, okay, set to 1, and then he announced the host A announced a sequence number that is A. Okay, then when the server receives this, we'll regard this as a request to establish the connection. Okay, so the server will confirm it. Once confirmed, then set the sync and then set the acknowledgement. That means I have received your sync packet. Okay, then in this sequence number, first the sending sequence number is B. That means the server A should use the B as the sequence number. Of course, it's a number, okay? For example, 1000. And then acknowledge to use the A plus 1. Of course, the A may be a number 2000. Then the acknowledgement means a number 2001. Okay, what's the meaning? That means I have received your data of 2000 before 2000, and then I want to receive the data from you that begin as 2001. Okay, this is the acknowledgement. Yeah, this is the second packet, and then next the third packet. Begin in the third packet, the host A can send in data. Okay, the sequence is A plus 1. That's the 2001. And then acknowledge the B and 1. That means I have received your packet that's before B. And then I want to hear from you of the packet begin with B plus 1. And then the flag is the ACK, acknowledgement. Of course, after that, the connection is established. Then they can communicate. Yeah, they can communicate, send the packet to each other. Okay, this is the establish of the connection. And then after the connection, they can send in packet. Okay, in the format we have discussed the window size. Okay, that means the host A can send in packet more than one at one time. Okay, here the window size is 3 packets. Okay, so the host A sending 3 packets. Okay, then the server A will acknowledge it. Okay, the windows is full. Then the server will acknowledge it. That means I have heard 3 packets from you. Then you can begin the 4th packet. Okay, then the host A will send in the 4th packet. Of course, 4th, 5th, and 6th, 3 packets at the same time. But in this time, some error happened. Okay, there's some mistake. That's the 4th packet is dropped. Okay, the 4th packet dropped, and then the 5 and the 6 have arrived to server A. But the server A did not receive the 4th packet. So when the server A to acknowledgement, what will put in the sequence number, acknowledge the sequence number, not the packet 7, because the false is not received, so still acknowledge the 4. Okay, that's the false packet I still not received. You need to resend it again. So the host A will resend the 3 packet. Okay, so this is the method of the TCP to repair the packet loss. Okay, when the packet is dropped, then the TCP can recover it. Okay, this is why we call the TCP a connection orient. Okay, this is a connection orient, can recover from sensing error. Okay, and then the flow control. Yes, the flow control I have already explained in the window size. When they establish the connection, the two each other will inform the window size each other. Okay, for example, the server A have informed the host A, my window size is 4 kilo. Okay, 4 kilo. That's 4 kilo means 4 kilo byte. Okay, byte. Okay, so that's how many bytes can you send at once without a confirm, without an acknowledgement? The 4 kilobyte. So when the host A is sending packet, it can sending packet 4 kilo within 4 kilo size at one time. For example, 1 kilo, 1 kilo, and 1 kilo, 1 kilo. Then the 4 kilo is 4. Of course, in here that's the that's 2 kilo. Okay, then the window size, the confirmation will tell the host A, the window size now left 2 kilo. Okay, left 2 kilo, and then I have already received 2 kilo from you. Okay, then the host A can send in 2 kilobyte at the next time, and then maybe the window size will be 4. Maybe the previous send packet have already processed by server A, so the window size still leave 2 kilo, and then acknowledged 4 kilo. Okay, then another 2 kilo can sending from source to the destination. Okay, of course, because the window size is 4 kilo, so you can send in 2 kilo at one time. Also, you can send in 3 kilo at one time, but no more than 4 kilo at one time, because the buffer, the window size, the window in the server A will be overflowed, so the packet will be dropped. So this window size just to control the speed sending from a source to the destination. If a server A wants to slow down, then just reduce the window size. Okay. If the server A wants to speed up to make the sending from source to the destination faster, then can increase the window size. Okay, this is the TCP's flow control is implemented by the window size. Okay, and then the TCP connection termination. Okay, this is the in the scenario that termination, the data communication is ended, then termination correctly. So the host first sending a packet with the finish flag set to 1, and then when server A received, then acknowledgement, and server A also needed to sending a packet with the finish bit set to 1, and then the host A confirm, then this connection is disconnected. Okay, the connection state in each computer will be deleted. Okay, as the connection is exist, the host or two sites will store the state of this connection in its memory. And then if we finished, then this state will be deleted. Okay, and we can see the TCP connection is the four-way handshake. Need 4 packets to interact between the host A and the server A, between the two parts. Okay, this is the TCP connection termination.